So we're going to continue with the problem where n equals the number of lawns that you've mowed and p is the profit. So in our table of values, each row represents a point on the graph. So n equals 0, p equals 0 is a point. And n equals 1, p equals 9 is also a point. N equals 2, p equals 18 is also a point. And you can continue to list out the points. What would the graph look like? Well, this graph is going to be pretty rough here. Remember to label your axes. This is n, the number of lawns that you mowed, p, the amount of profit. Our values, can I pull this over and still have enough space here? Our values are 0, 0. How about we do this in a different color so it's really obvious? 0, 0. 1, 9. Ooh, where do I put the 1 and where do I put the 9? This would be a lot easier if I label the axes. You should always label your axes. So we have 1, 2, 3, 4, and 5 for our n values. For our p values, well, they're almost going up by tens. Your highest value that you should have gotten would be 45. I had to do that special multiplying by 9 rule where you put the finger down. Do you know that rule? That's a great one. I use it all the time. So we need to get up to almost 50. And it would make sense for our scale to go by tens. 10, 20, 30, 40, 50. I think that's pretty even. Sometimes I have to erase and start again, but I think that one will do it. Now I didn't leave much space here, but usually beside all these numbers you would put that the units, and this is in dollars. So normally you would write it over here. I'm out of space, so I'll write it there. Okay, so our next point is 1 and 9. So 1 is our n value. It's on the bottom, the horizontal axis, so I will place it around there. And 2 and 18, it's almost at the 20 points, so 2 for n, we go up. Here are the possible 2 values. Let's just kind of shade this in and do it slowly. The possible 2 values are around here, and we're looking at about here for 18. So this is the point where 2 and 18 match up. So that point is 2, 18. We can keep going with our other points. 3, and you should have 27 for that one. So I'm going to line that up. I go up 3 all the way until I get around 27. Okay, you can continue doing this for the rest. So this graph is a pretty rough graph. It doesn't look all that fancy, but it gives you some important information. For the number of lawns that you mow, you can figure out what the profit would be. Now this is called a discrete function. It doesn't really make sense to mow half a lawn and get paid to do it unless you're offering your customers, okay, you can just have the front lawn mowed or just the back lawn mowed, but definitely you wouldn't have a quarter lawn or a 3/4 lawn or anything like that. In this situation, let's just say you've got a flat rate, one lawn, no matter what size, no matter if it's just the front or just the back, no matter what, you're charging $9. That's it, that's all. So this is a discrete function because the values in between, these values in between are not really points on the graph. However, in some situations, you might want to know a value in between. Maybe you need to make $40 and you'd like to figure out how many lawns do you need to mow to make $40. So you might want to find the point on the graph and go from there. So this looks like it's about 4.5 or so. 4.5. And 40. But if you're trying to figure out how many lawns do I have to mow to make $40, you would have to round it up to 5 lawns, because after you've mowed 4 lawns, you don't quite have $40. So you have to mow 5 lawns and get $45. It'll be a little bit extra, but that's the only way to make sure you have $40 in your pocket so you can go out and buy something that you've been looking forward to having. So when you have a set of data points, these ones are going to go up to here as our last value that we had. When you have a set of data points that you've graphed and you figure out a value somewhere in between what you've graphed, this is called interpolation, because you're looking into the middle. If your graph only went up to 5 originally, but you'd like to look at, well, in the future I'm hoping to expand and maybe get up to 7 lawns. How much money would I make? You can use your graph. 6. Oops. 7. You can use your graph. If you can get up to 7 people, approximately what would that be? If you continued your values up here, that looks like it would be around $60 or so, maybe just over $60. So when you go outside of your data points to try to find a value, that's called extrapolation. So inside, think interstellar, between planets. Extrapolate, that could be like extraterrestrial, outside of this world. Intra, in, extra, out. Okay, so I'm gonna add that in for now. And I want to show you, I embedded some practice for you to do with graphing software called GeoGebra. So I want to show you how that works. This is what it looks like on my end. Oops. Okay, so this graphing software is called GeoGebra. I'll probably give you lots of opportunities to use it in this course. So you can click here and add input. It could be an equation, but in this case, it's going to be a point. So our next point was 3. It doesn't like spaces, I don't think. 327. So they're calling that point D. Okay, so this graph looks very similar to the one that I drew by hand. It's just a little bit neater. 45? No. 36. Okay, so now we're starting to see the data points here. And again, remember that because they're points and the values in between are not really part of our situation, mowing lawns, it's called discrete. If the points worked for every single possible little itty-bitty rational or irrational number, like if we had 0.1 makes sense, 0.05 makes sense, the square root of 2 makes sense. If all those numbers were values you could put in for the number of lawns mowed, then this would be a solid line and it wouldn't be discrete. It would be called continuous. Okay, so this is the graphing software. It's here for you to have a chance to check out. Maybe you can figure out what's an equation that I could make that would go through all of these points. What do I have to do to n to get p? Well, I think by default this program probably used x and y's, so let's use x and y's as well. Let's see. Y equals, we were doing something with 9s. Maybe it's plus 9, x plus 9. Maybe that's the rule. Does that look like it goes through the data points? No. Okay, let's try again. Let's double click on that. It's going to let us edit it. Well, it's just not big enough. Let's try a bigger number. Maybe 18. Oh, that just made it jump higher. How else can we get a bigger number? Whoops, I pressed the back button and I lost that graph. Okay. So we lost some points, but that's okay. So we were playing with y equals x plus 18. Okay, so that wasn't working, that wasn't going through the points. We need it to come through the point at 0, 0. Maybe y equals 2x. Okay, that went through one point, not quite all the points. So I want to leave you with this graph, with the GeoGebra graph here, and graph the rest of the points, and see if you can find the equation that goes through the points.